Okay. All right. So this piece of code here is the first piece of code you would see probably when you log on to your IDEs. The one we're using is your Apache NetBeans. I'm sure you're all familiar with that. And what it tells you here is that you're having a class that tells you welcome one, and you're having a main, which is your public static void main. And the main, as we know, is where every program launches from, right? So even though you have a class in Java that has been written with some instance variables declared, if you do not have a main, the program will not launch that application. Now, there are several things you should be reminded here. One of such things are how to do comments, right? We do a multi-line comment, a single-line comment. You also know that you identify a body of code by its curly braces. So most of the times you see where you have a class, it starts with the left curly brace and ends with the right curly brace. And everything written in between are basically the lines of code that will function within that space. All right. So Java supports the same idea of comments like you know in other programming languages, or specifically like you know in C. And at the last points there, it's pointing out to the various errors you can have: syntax errors, logical errors, semantic errors, compilation time error, and so on and so forth. All right. I'm just breezing past this concept because I know you're familiar with it already. Or rather, I choose to believe you're all familiar with this. All right. If you go into Java, the first thing you should be reminded about are classes, methods, and objects. All right. What is a class? If I should ask, what's a class in Java? Do you remember? Or you've forgotten it already? You don't know how to define it. Say it anyhow you think it's correct. Say it anyhow you think. Say it. Say something. No comments?
The outline of an object. You need a flow to create an object. It's the portal of an object.
You're not butchering that, Alan. You're butchering it. Yeah. All right. So it's a blueprint. All right. So a class is basically a blueprint of your program. It tells you what to expect when dealing with a specific object, or I'll use the word object, or a scenario. And if you want to understand blueprint, you look at, let's design a car, for instance, right? So in designing a car, you draw your specifications. You know that the car would have some body framework, the engine specifications, number of wheels, and the gear shifts and all that. So those aspects, those things you tick, like, okay, this car must have this, define what the blueprint will hold. Now, that's just a sketch, a model on paper, an idea, which is what's called a blueprint. However, that specification can now be, you can now create different objects based on that specification, or different instances, all right? Okay. An easier one will be this, all right? If I ask you what is a blueprint of what a man should be, all right? So it means, or a human being, I'm not using the word man, but a human being in this case, all right? It means somebody that has one head, all right, 2 eyes, 2 ears, and a mouth, probably 5 fingers, not 6, all right, and 2 legs. But we can have them male or female, all right? We can have them tall or short, and these are the various variants that comes out from the blueprint called man, all right? And that's what a class is. It's basically a blueprint that tells you how to declare certain aspects, or what comes with certain aspects of your code, what comes with certain scenarios or design of your program. All right. So when dealing with classes, one thing to remember is that the class name, all right, starts with a capital letter. Always starts with a capital letter. So if you launch your program now on Apache NetBeans, you will realize that it will start with a package and a class. Usually the package name and the class name are the same thing. In fact, the class name and also the constructor you have underneath will be the same name. And if the name tend to differ, you find out that you start having problems within your program. All right. Java is very case sensitive. So if you're declaring any variable or any name for a class or for a variable, local or instance, you have to be specific. If it's a lowercase you're using, stick to lowercase. If it's an uppercase you're using, stick to uppercase. Otherwise, if you combine both, you're going to have several errors. All right. We know what a Java virtual machine is. It exists in most platforms, Windows, Linux, and so on. But that's the machine that allows you to run your Java code. All right. We say Java is platform independent, so you're not stuck to one specific platform. It allows you to run your code. So I can design my code on Mac OS, for instance, and send it to you who has a Windows system, and you're able to run the application successfully without any issues whatsoever. All right. So the piece of code we see here shows us line 6 to 10. The first one says public static void main. It's ready? Okay, I'm coming now. Public static void main. So if you look at the description there, one of them is a specifier, which is the first one, public. And public tells you that you're making this specific method accessible to several other methods or classes. All right, and sometimes you would want to do that, but sometimes specifiers are either private, restricted, depending on what you're trying to develop or design. And we'll probably look at that as we go forward. All right. Static there is the modifier, signifying that this is static. And obviously, we know what static means that it does not change. Void is a type which tells you that there is no return, or what the return type will be, or there's no return type in this case. And main is the name of your main method that launches your program, right? Obviously, any variable you see with a parenthesis is what defines what a function. So the parenthesis is where you're now feeding parameters. In this case, you have string adds there, taking in no parameter whatsoever. In line 9, we see our first printout statement, which is system.out.println. System.out.println. All right. We know already from what we've done in Software Design 1 and in other courses that you have several print options in Java. You can write system.out.print, which prints your information or what your argument is in a line and leaves the cursor in that specific line. You also have system.out.println, which is what's written here. And that ln there tells you that the cursor moves to a new line after the print. And you also have your formatted print, which is your system.out.printf, where you can now specify different format specifiers or placeholders to capture your data. And for format specifiers, you have your %d for your integers, F for your floats, S for your string, and so on and so forth. You're familiar with this concept already, so I'm just trying to brush up because of time. All right. All right. So the next slide begins to explain the various escape sequences you would encounter within your program. All right. And obviously, you're familiar with some of them, which is your /n, which tells you go to the new line, T, which is the horizontal tab, arrow, which is the carriage return, your backslash, which prints a backslash character within your program or within as an output, sorry, and the double quote, which helps you identify what your string type would be within your program. All right. The formatted print functions, which is your printf. Again, we've explained this. It allows you to print your output in several desirable formats. For instance, if the user enters an integer, but you're printing information out as a string, you're able to use the format specifier to allow that information that has been captured or read from the input to be fed into your string and come out in the desirable output form. In the example here, we see in line 9, system.out.printf, and in there you see your double quotes. The double quotes there signify that this is going to be printed as a string, all right? You also see your %s signifying the format specifier for a string. Your /n tells you take it to a new line after that. Another %s and /n to go with that. Then you receive the inputs that are fed into those %s's, which are placeholders. The first input is welcome to, and the second input is what? Java programming. So it allows you to now print that information and puts it in separate lines. right? Um, like always, the first thing you do in a program is try to add numbers. Try to do some arithmetic first. Write a simple program that allows you to add two numbers together and print out a desirable output. In doing this simple exercise, most of the times you discover that you begin to learn how to receive information from the user. How do I receive the input from that user? The inputs require you to import several packages or modules or APIs. In this case, the scanner module is imported into your program. So you always write an import before your class, not after you've declared your class. So for instance, in line 3 there, you see we have import java.util.scanner. So go to Java directory, look for the utilities and pick out the scanner. The scanner is the API that allows you to read every input information you've received. If I was to relate that to C program, that would be like using scanf to receive the information in this case, all right? So like always, every of these modules are written with an object as an object in mind. Those objects have several attributes, several behaviors, all right? And how we use objects is to create instances of them, all right? So the scanner module has been imported, but we'll create an instance of that scanner module, which is given to here as input in line 11. So when you see scanner input, the name input is a variable that has been chosen to take on the properties of scanner. So going forward, we will not be using scanner anymore, but we'll start using input to be able to interact with the behaviors or the attributes or the method that are associated to that specific object, right? So in line 11, we see scanner input is equals to new scanner. And when the keyword new is used, you notice that it's shown in blue there. So those keywords are basically words, obviously you notice, that are meant for the program. So you cannot specify them as variables or declare them as function names within your program. All right. So scanner input is equals to new scanner. Then in there, in the parentheses, you see system.in. What does that represent? Any ideas? System.in. What system.in? The input what? Good, the input stream, all right? So we have three streams that we've identified in our programming languages: the input stream, the output stream, and the error stream, all right? So the input stream is signified here as system.in. If it's the output, it's system.out. If it's the error, it's system.err, signifying that you're able to catch several errors that have been thrown within your program. All right, line 13 to 15 there are now declaring local variables, which are your num1 or number 1, number 2, and your sum. All right. Again, the goal is to add integers together. Now, in every program, you prompt the user because as a programmer, you're going to direct the conversation. So you tell him, okay, enter the first number. You give him the opportunity to do so. And you see in line 18, we see system. You see number 1 is equals to input dot next integer. So what you prompted the user is to enter an integer, and what follows afterwards is how to receive that integer. No more scanner, but now input, because input is an instance of scanner, or it's an object that's created out of scanner so that we can interact with the object and its associated functions or methods. The method we identified there is what? Next int. All right. So you see when you have the dot, that dot allows you to associate with several methods or attributes that are linked to that specific object. So if you see a dot within your program, sometimes you see a list of several functions or methods that will be shown to you. And in this case, because we want to receive an integer, we're receiving the next integer that's been entered into our program. The same thing applies to the num2, and sum in 23 there just adds number 1 and 2. All right, so your normal plus sign does that, or arithmetic operator does that probably very well. The output is shown in line 25 there, system.out printf, and again, a format specifier has been used to take in the value of sum and feed it into the string, double quotes there with the percentage %s. there. All right. So if you break down that piece of code we just saw now, you see several aspects of it. You have your scanner module, which allows you to read in information. You have your system.in and out, which takes in the information and also prints them out as well. You have your new, which is the keyword, allows you to create a new object out of a specific class. In the scanner class, we've created an instance of that as an object, and we called it what? Input. Now, it doesn't mean that input is standard. It just means that you can give it a name to whatever you're creating. All right? Okay. So a scanner enables a program to read data, which is number string, and use it in a program, all right, as we've seen already. All right, so adding integers. If we try to recall, we have your primitive types and your reference types. Your primitive types are listed here, like your booleans, your chars, your shorts, integers, floats, doubles, and your reference types are your string or any user-defined types that you would know. Right? In the course of our of the semester, we're going to stumble and use most of these types in writing our programs. All right? Okay. One of the things to also have in mind is the order of precedence, especially for arithmetic operations. All right. So if you see things like this, at times you would think that by adding it from left to right is the right way to go, and you end up having the wrong answers. So in this example, we see here that we have say Z is equals to P times R modulus Q plus W divided by X minus Y. All right. And we also have the one beneath Y is equals to A times X plus B times X plus C. If you give values to this specific symbols or letters and run the program, you will notice that you have some output. But if I ask you to calculate this by hand, most of the times you make a mistake with this. And that's because there's an order of precedence. And the table on the left-hand side is trying to explain just that. So what takes more priority when dealing with several arithmetic operators, right? Your multiply or divide, your additions, modulus, and the rest of them. If you look or even go to YouTube to Google most of this, you will see that there's a list of order of precedence in terms of how several operators functions. And there are a lot of them, from bitwise operation, logical operations, your arithmetic operators, and so on and so forth. They all have an order of precedence, all right? Some take from left to right, so it means that once you're performing the operation, you consider what's on the left first and now go to the right, and things like that, or vice versa. All right. In this case here, we're now trying to see how we can compare two numbers. All right. So we have the user enter in num1 and num2 again, and we now use some relational operators to see if they are equal to, not equal to, less than, greater than, or less than equal to, or greater than equal to. All right. These symbols are familiar to you, and I'm sure if I ask you to put up your code right now and try to attempt this, you probably finish it in less than a minute. So that is me assuming that that's possible. All right. But again, this here are basically things you're familiar with because we did it already in our earlier classes. Now, an exercise is shown at the end of this slide. And what the exercise is trying to do here is to now get you to now write probably the first bit of code that allows you to perform several arithmetic operations. All right. The first one is asking you to enter two numbers and find the sum, product, difference, and the quotient or division of those numbers. All right. So while you try to do question one, I will go and sort out the other venue because I think they're ready to be set up. Then I'll come back and continue the class. So please, everyone now, if you can hear my voice, log on to Apache NetBeans and try and perform this exercise, especially 2.13, 2.15, sorry. Yeah.
whole thing. Don't keep the same thing. What's finished? What's honest? You standard over the nice. Wait, yeah, you can call. No, you might see the double in it. You make it up.
Some of you are on top of the massive others. All right, because of time, I'm going to have to pause you guys where you are at the moment. All right, so we can move on to the next topic. All right, I'm trying to recover lost time here. So the next thing we look at now is your object-oriented programming. We now take a more in-depth look in terms of what we know in Java. For instance, I'd mentioned already a class, method, instance variables, But in this part of the lecture, we begin to see their definitions, which we'll just skim over and go into the main meat of the matter. So again, a class is a reusable software component defined in terms of attributes and behaviors. I kept mentioning attributes and behaviors, right? If you were to write a class for dog, all right, say to create an animal dog, and dog is a class, a dog will be able to bark, be able to bite, be able to eat, sleep, and several attributes. So those things are rather the methods. The method is that a dog object can bark, can bite, can sleep, and can eat. And the attribute will now be that the dog has maybe its stature is small or it's big, maybe its eye color is blue or it's brown, maybe any other things related to its features, all right? The same way we can look at a class in that same manner, because a class is basically a blueprint, and when we look at the blueprint of what we're trying to design, it will have several attributes and also have several behaviors, right? The behaviors are what we refer to as our methods or the operation that that object can take, those things it can take, all right? Methods perform a task in a computer program. Methods performing a task in the computer program requires a method which defines the program statement that actually performs the task. So in the behavior, we now specify this is what the dog can do. So we now specify within that body of code that this bark means that this. So we now write our line of code to what we tend to associate as a dog barking or describe as a dog barking, right? Objects will have attributes. I've said that there are features or properties or characteristics. If you're dealing with a car, you're talking about the engine type, the color, the body, is it a hatchback, is it a sedan, and things like that, all right? Classes can also be encapsulated. Encapsulation means that we're going to wrap these attributes and methods or wrap the attributes and behaviors together so we carry them along, all right? So whenever you hear the word encapsulate, it means that we're going to be wrapping it in some form of class and taking it together, all right? It's also very important that we can hide information as well. So you see that when we talk about our main method, which is public static void, remember the word public came up. When we define the class, you see public coming up. But public is not the only specifier we could use. We can use private, especially if you want to restrict access to that specific method. We can use restricted and other specifiers as well, all right? To instantiate means create an instance of a specific thing, an instance of an object in most cases. So where we have scanner, like we did in your example just now, you see scanner input equals new scanner parentheses within the system.in. The scanner and new, which is on the left-hand side, is telling us that this class and the input, which is the variable beside it, is now an instance of our scanner. And the new keyword is what instantiates it. All right, so it's possible. Right. A method call is like calling a function. So if you use the word method most of the time, it's simply like saying a function, and we can write that within our program to call and access several objects or properties. Now, if we make or we declare variables, the variables that are declared within a block of code are called local variables, all right? But the variables that are declared in the class, not in a method, are called instance variables. The instance variables can be associated as private and can only be accessed through a method. So if we declare something as private, we're keeping it restricted in that class. However, a method itself can take it as an input information and use that operation to update the information. Use that process to update the information that's that. We'll see some examples soon. All right. So here we see object-oriented analysis and design. All right. If you're trying to develop your program or trying to develop a system of some sort, your design requirements will have to be done in such a way that we can view the layout of what you're trying to do. Let us see conceptually, let us see how your program would function, all right? It means that if I say, let's design a system that monitors attendance. So if the student comes into this class now, it monitors number of swipes and obviously who comes in, who goes out, or who didn't attend that day. It's possible. But to design such system, we must first of all plan it down, right? Create a way where we can see these objects and how they interact, and it will now make our designs or our programming a bit more efficient and more cleaner, right? The UML comes into play, which is the Unified Modeling Language, right? It's used widely to show graphically what your design will look like, right? There's some examples. I hope we get to that in time. All right, so here we see a class called Gradebook that contains a method called displayMessage that displays a message on the screen, all right? So if you look down there in figure 3.1, you see public, class, gradebook. Public telling you that it's accessible. Class is the keyword to say they were creating a class, and gradebook is the name of that particular class. In line 7, we now have public, we have void, and display message. So line 7 there is where we're describing a method that can be used within that class called gradebook. And the only method defined here is that we're able to display a message. The message is written in line 9, which is what? Welcome to gradebook. Welcome to gradebook. And take note that we're using print ln. It means that once we print that information, the cursor goes to what? To the next line. Okay. All right. So here we see a class and gradebook test. It is used as a Java application program that we use to test the operation of the class gradebook. So we've created the first class, gradebook. The next one is now gradebook test, so that we can see how these two classes will interact. We use one to test the other. They also can be referred to as the driver class. It contains the main method. It contains the main method, and everything we know launches from the main method. So that's our driver class. Although we have two classes, one does not have a main, it only has a function or a method called what? Display message. While the next one, which is the test, now has the main method that will now be able to perform the required operation. Okay. So the main method is static because we can call it without first creating an object of the class in which the method is declared. All right. In order to call a method declared in another class, we need to instantiate the object of that class. So if you look here, we see in line 10, gradebook is our class we saw previously. We are trying to create an object of that class. The next thing we see is my gradebook, which is the name or the instance or the object created from the class called gradebook, is equals to new gradebook with our parentheses. So by doing line 10, we're now able to create a copy, an instance of what gradebook will be. It means that that instance, my gradebook, will also have access to the method called what? Display message. Is it clear? Are we together, guys? Okay. So in line 13, you see my gradebook.display message, and that's possible because we know that my gradebook is a copy or an instance of the class called gradebook. All right. Line 10 makes use of a constructor, which is a special method used to instantiate an object of a class. And when you look at that code, sometimes if you're obviously familiar with Java, you will say, where's the constructor? In this case here, all right? But we know that we have default constructors. And default constructors are constructors that run where we don't explicitly describe what the constructor should be, all right? The constructor usually, when explicitly defined, will have the name or the same name as the class, and will take in the instant variables as its parameters to instantiate those parameters so that they can be used within our program. So in this case, we use the constructor for my gradebook, and we're able to now use the method .display message to give you or to invoke the desired outputs that we need. All right. So we talked about UML just not too long ago, the UML diagram. So in UML diagrams, it's a graphical way by which you can show how our classes are designed. We have a class diagram in this case, and a class diagram will show you the attributes and the behavior of that specific diagram. For instance, in this one here called gradebook, we see we have several sections. The first section here is the class name. The class name here is given as gradebook. The next section here, though empty here, is where attributes are usually written. The attributes will be written like it's black, it's white, or any other thing that specifies to gradebook. And the last one here is the method or the functions that applies to that gradebook, which is display message. And you see that in your parentheses because we know that any variable with a parenthesis is basically a function, or in this case, a method. Right? Okay. So the goal of this is that at the end of the day, we should be able to now visually see your design in a UML structure and see how the various methods and classes interact, and be able to come up with a program that establishes that relationship. All right. Okay. So a method may require additional information from the calling environment to perform its tasks. This additional information should be specified in the method defined as parameters. So it means that a method is able to take in some form of arguments within its program to perform the desired set of instructions and give desired outputs as well. Right? Okay. So I don't dwell too much on the write-up. Let's look at the code here. We see public class gradebook. In line 7, public void display message. And in there, we see string course name. So course name is fed as the parameter to this method. And we can now see that we can use it as an output when we say system.out printf. We have a %s within that string there that takes in whatever the course name is and displays that to the console for the user to see. Any question at this point? No? Are we all together? Okay, let's continue. So here we see class grade test is used again, and within the code we've imported the Java or the scanner app. So java.util scanner. Our public class is described as gradebook test. Then our main is also defined here in this test class. And we have an object of scanner created called input. We have an object of gradebook called my gradebook. And we now prompt the user for the required information. So basically enter the course name. The course name is entered and saved in name of course, which is a string. And we now say system.out.println, which now prints the output as blank in this case. And the last one here is my gradebook dot display message. The dot there associates it with every attribute or method that that specific object is linked to. And that's why we have the name that was entered by the user will be displayed on the screen. All right, so you have these exercises, guys. You can also try it when you get back and just see if you get the desired outputs as required. All right. So in this UML diagram here, we see that before now, we just had display message with no arguments. But below that, we now have display message with the argument called course name, which is a string. So it tells you that in this case, it might require a bit of more information to display that output accurately. So when you write your code, obviously we know that if you remember what we did in programming in C, we said that there can be 4 kinds of functions, or I mean use the word methods now, which is one with arguments with no return type, one without arguments with no return type, one with return type and no arguments, and one with return type and argument. So in the same way, these things apply even here in Java. So in this case, we are having display message, but now we're now having arguments related to that. The display message may be void, meaning there's no return type because we're only printing out things. But in some cases, you might want to give a return type if you expect to take the output and perform other operations along the line within your program. Okay, so I already explained what local variables are. Variables that are declared within a block of code, so within a function, within a method, and things like that. While your instance variables are declared in the class, they are not linked to any method of whatsoever. All right. The class attributes and the methods are explained as well before now. And the last thing I highlighted there is whenever a class has an instance variable, it's customary to provide a method that is used to modify or access the instance variable. and they are referred to as set and get. So the set and get method are what we use to now access those instance variables that have been declared within our program. For instance, we can use set method to receive the information that's entered by the user, and get method to display the information provided by the user. They are not default methods. You will have to write them yourself within your program to set and to get, depending on what your operation looks like. There's some examples we can look at here. We see in figure 3.7 a class called gradebook. We see that we have void, public void set course name. So this is set method in play here. The input there is called string name, all right? And within there, we now have course name is equals to name, all right? So whatever the course name is, it is given an input as the name there. So we now have public string get method, or get course name rather, and we are returning the course name that has been set already in the previous function back to our program. And here we now have public void display message, which is your system.out.println, line, and you can see that its input that feeds to the %s is actually a method, guys. The input that feeds in line 27 here, this input here is a method called get course name. What has been described here? It's not just a variable. It means it will allow you it will perform the function of the method described, and what is returning back in this case, course name, is now fed as an input to be placed at the percentage holder %s, or the format specifier %s. Are we together?
Yeah.
Okay. All right. Now we've seen that the gradebook has adjusted. The initial class gradebook wasn't this way. All we had previously was just display message. But now what we're doing here is that we've now created two other methods to display message. And the first one says set course name. The second one says get course name. And that's able to interact with our method called display message as our output there. All right. So what we have on the side here on the right-hand side says instance variable course name is declared private to restrict access to it. So it means that line 7 has made course name private, but the only way we can actually access that information is through a method. All right, this is referred to as hiding information or encapsulation, and it's considered good programming practice. The next one, the only way to access instance variable course name outside of class gradebook is via public method, which is your set course name and your get course name. All right. In our class gradebook tests, if you're using the modified gradebook, we'll see here that we're now able to, in our main, creating a new scanner or a new object of scanner, creating a new object of my gradebook. We now see that my gradebook dot get course name. So my gradebook is the object we created earlier that only had access to one method, and the method was what? Display message. But because we've updated my gradebook with set course and get course name, our test script now is now able to access this method with the dot operator that associates that. Okay. So let's look at our UML diagram again. The original one, or the previous one, was the method there was display message, and it takes in course name as a string. But now we now have our attribute, which is course name as a string, and our method is set course name, get course name, and display message. We now have three methods associated to our UML diagram in this case. Okay. Yes? What are the plus and the minuses for? Okay, so we have, okay, how will I explain this? Let's say, let me use what? This is private to the class gradebook, while these are public in their descriptions, all right? So you can't access this except through these methods here. So this allows you to receive the information straight, which is why when you write it in your UML diagram, you show that this has been declared private, while these have been declared public. Yes?
So those are used for the X's to put on.
Sorry?
Are those used to access?
Yes, we just showed that in the last example, remember?
Will I use a class if it's not, it's like a public variable?
Yes. But most of the good programming practices that when you have a class, you define its instant variables as private so that you don't have other people changing the information within your program. All right? All right. Okay. The next thing we look at is constructors. All right. So we require constructors, and there are special methods that we use to instantiate the variables in our class. So we know that they have the same name as our class. So if your class is gradebook, the constructor will also be gradebook. The same name, the same case sensitivity. If you're using a capital G, stick with it in that same way, capital G, ultra. All right. Okay. So constructors are normally declared public since they have to be used by other classes to instantiate their object. So if we have, let me see, I think it's an example here somewhere. Let me see. Yes. So in this example, highlighted from line 8 to 12, where you see public gradebook there, notice that the name gradebook is similar to the name, the class gradebook, in the same way it is written and spelled, all right? But the constructor allows you to take in arguments, and the argument you're taking in here is the private string course name that has been taken in here. So when that name comes in, we now initialize that name by saying course name is equals to name in this case. Or like we did previously, we say this dot name is equals to name. So the this keyword allows you to instantiate an object or instantiate that specific variable, instant variable. All right. So every other thing applies. Like we know the set course, get course, and display message. The only difference now is that before we did not explicitly describe the constructor, but now we are now trying to explicitly describe the constructor so that we are able to see what parameters it can take. If you have, say, 2, 3, 4, 5 instant variables, you can as well one or more of them within your constructors so that they're accessible within your program or initialized within your program. Right. So here in this last example, we have our gradebook test class. In our main, we have the gradebook 1 and gradebook 2, which are objects of gradebook. It means that they are instances of that class called gradebook. And we also have them access the functions get course name for gradebook 1 and gradebook 2. So it means if we use this gradebook test and run it with the updated version of gradebook, we should be able to see some interaction where we can get the names of those gradebooks. Okay. All right. So here we see our constructor gradebook name added to that part of our UML diagram. Now, there are exercises here for you to try, but I have one I was preparing for you guys. Let me just see if I can pull that up here. Okay, so this here is a UML class diagram for a library management system. It's just simple stuff, but this UML diagram here shows you that we have 3 classes. We have your book, your members, and your library. All right. The book there has 3 instance variables: title, author, and ISBN number, and 1 function, which is your get details. The members there have 3 instance variables: name, member ID, and borrow list. And we have a function called borrow book. And the library there has 2 instance variables: books and members. These books and members are basically taking the information off the other classes and feeding it to the library class, which is why you see the arrow pointing down there. All right. So it means books will have access to the object. It will be an instance of the object books or book above, and members will be an instance of the object member from the class above. Right. Then there we now have 2 methods, which is add book and add member. If you look at this, you see. Okay, let me open the other one I did. Let me see. Just give me a minute. Where is it? Where is it? Where is it? Right. So I used draw.io to achieve this yesterday. You will see that what you expect here is that what's coming into library, it will be an array list because you can have one or more books and one or more members. So you have to import array lists when doing this exercise. You also know that there's a main. So far, we've described only 3 classes, but there's a main class that launches this. Without a main, it will not work. Because notice, I didn't put any main method within the initial classes. So instead, I'm creating a main class that has the main method to run that program, right? I know we are out of time, but it would be good if we can do this exercise um, um, maybe when you get home, because on the practical next week, I'm going to create several instances of this that we're going to attempt to do within that time. Okay? Yes. Just let me finish up our PowerPoint. Yeah, so we are out of time. I believe the class ends by 9:50. Yes. So I will take a screenshot of this and put it up on Blackboard so that you can attempt to do this in your spare time. Everything you need to know how to do this is shown to you in the slides we've covered today. You know how to write the methods, how to write your instance variables, you know how to import your scanner app. The only thing I added there is to import an array list in which you can use to access the variables that comes in from books and library. That's because the associativity is one to many here. So array list can handle that information here. Okay. Yeah, that's all. Okay. That's all. There is a register. I'll put it up now. So I'll make the tutorial available on Monday, right? Again, another tutorial, and on Wednesday I would create several scenarios or several examples such as these, where we'll actually be either writing our UML diagram ourselves or seeing the UML diagram and writing what the program will look like for these several classes to interact. Is that fine? Okay, let's look at the attendance. All right, click on the register. For lecture, just tick on your name for today.